is take some kinds of data sets and say here are the ways in which you might want to represent them, and the different ways in which you represent them will lead to different interpretations, and therefore you have a choice. Say, I want to communicate this kind of message, and therefore this is the kind of representation that I want to pull out and show. So here is the tabular representation, and I'm starting with the tabular representation because that is on the one hand the easiest to do, and on the other hand is also the easiest to improve on, which is the polite way of saying the worst possible representation you would ever want to show. So let's start with this. The data that I'm going to use for the next about 15 odd slides is district-wise, I think it's rainfall, let's say it's rainfall, for each month of the year. So about 12 months, actually it's much more than 12 months, it's about 100 years worth of data in this table really. So about 1,200 months worth of data for each month I have the rainfall, and this is one possible representation. Just show it on a table and people will get nothing at all out of it. Or you could put in little bars inside. This is something that Excel supports. This particular visual is done in Excel. And you can straight away see that in February there's been no rainfall anywhere, whereas in April, May, June there's been considerably more rainfall. July seems to have a dip, August seems to be pretty good, January seems pretty average. You get a sense of where the monsoon is in Tamil Nadu. Or you could use colors, which gives you the same pattern and in a different way. Now, I'll explain where colors score and bars score. But here, for instance, it's very easy to see that there's been absolutely no rainfall here in February. There's been literally little rainfall in Krishnagiri for 2 months. Madurai suffered in this period. July has been bad for Dittukal and Erode. Kanjipuram is bad in a couple of areas. Now, notice that as I was doing this, I was picking contiguous areas that had low rainfall. Now, here's an important thing about contiguity or proximity. When two things are close to each other, I naturally tend to group them. The groups sort of stick out. Now, a horizontal grouping here is perfectly reasonable because it's January, February, March, it is consecutive months. A vertical grouping is absolutely unreasonable. There is no reason why, when I arrange these alphabetically as I have, a combination of these should represent anything meaningful, and yet to the eye it will, especially when you're using colors like this. So, the good thing about a table where each cell is colored is that you can quickly see differences across various regions. What is not necessarily good about it is the way in which we tend to form blocks about contiguous areas when we should not be forming such blocks. If you had data that was, for example, January to December and 2001, 2002, 2003 and so on, then it makes perfect sense. So you're forming a block by year as well as by month. Perfect. That's exactly the way in which you want to represent this. Going back to incel bars, here it's very easy to compare the relative magnitude. So you can say that's about half of this. Now let me take Dindigul and Erode in March again. Dindigul and Erode in March. I can look at the numbers and probably say that it's about half, but that's a lot more cognitive load, or about as much cognitive load as saying this color is less and darker than this color. I can't compare these. Now with bars like this, proximate comparisons, not proximate, vertical comparisons are easy. So if it is important for you to be able to compare the rainfall vertically, for example, if this were years again, you would want to see in 2001 versus 2002 versus 2003, in the month of March, has my rainfall increased or decreased? What is the pattern? I want to be able to study this relatively finely. That's something bars can do. Now, humans have an ability to perceive visuals in a somewhat systematic way. That is, there are some things where we perceive differences much better than others. We perceive differences in position reasonably well. Not reasonably well, rather than. So, if something is to the left of something else, and if we happen to associate left as less and right as more, then you'll be able to see it. If you wanted to arrange a bunch of numbers, just the easiest way to differentiate them is to put a dot for each number and use the position to differentiate. As opposed to, for instance, there are many things about objects that you can use to differentiate. One thing you could use is size. You could say, I'm going to draw 10 circles. The size, the area of each circle is representative of the value. Comparing those, very difficult. Or I could say use angles. I'll draw a pie chart. Comparing angles is even tougher, even when they are more proximate. So we are reasonably good with position. We are reasonably good with size. We are pretty bad with we're reasonably good with position. We are slightly worse with size, but not too bad. We are pretty bad with angles. In fact, I'd be hard pressed to find something worse than angles. Maybe shapes, triangle versus rectangle versus square. Yeah, we can do something with that. But while we are on the topic of angles, I'll mention this once and I'll try and mention it as many times as I can. The worst possible graphic or chart from a visualization perspective is the pie chart. Because it is possible, no matter what interpretation you want to draw out of the pie chart, it is always possible to create a simple visualization that is better than it in every way. It's, it is Pareto suboptimal, if you will. Every single aspect of the pie chart can be bettered upon. And therefore, it is considered good practice not to use the pie chart unless you're trying to actually show what a pie chart is. For the reason to ever use it. So,
then why it is commonly
because it looks nice, round things look nice. Why are red and bright blue used in all those jarring color combinations? Because people don't have a sense of color. Why do
That's so true.
before I hit you or hit anyone else in this room. So it is commonly used for probably the same reasons that Comic Sans as a font is commonly used. For those of you who are not aware, Comic Sans is a font that was created by Microsoft, meant for use in comics. It is generally considered the worst font ever created. Not because it was created by Microsoft. Microsoft created some good fonts. And people who, yesterday for instance, I was at this conference called PyCon, and somebody started tweeting saying, look, this dash 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 is using Comic Sans for displaying code. Somebody else followed that, somebody else tweeted about the same thing. It's like horror of horrors. How could anyone show Comic Sans? There are websites designed in Comic Sans, and there are both websites that talk about websites designed in Comic Sans and say, oh, bad here. Pie charts are like that. They are bad design decisions, but you find them used in a lot of places because it looks somewhat different. It looks nice. If I want to represent a percentage, pie chart looks like a natural thing, and because we were taught about pie charts in school, because Excel has pie charts. The world will improve when Excel removes pie charts. Sorry, somebody else had a question?
Oh no, I was just going to ask as well because yeah, pie charts are the most commonly used, and I agree. I mean, I completely agree with you. But it was the same question that he asked.
In fact, let's after a while, if we have time, we can talk about what are the charts that are better than pie charts. But as a simple rule of thumb, just use bar chart instead. At least you'll be able to. If you have a pie chart that contains 10 values, then rather than comparing the angles, the bar chart will let you compare very granularly what the value is. Take this column for instance. I can very easily see that Madurai had the highest rainfall in April, followed by typical very little rainfall in Kanchipuram, but then compared to Kannur, it's even less and stuff like that. Which try doing it in a pie chart with the same thing. You will take 5 times as long if you're at all able to do it. Or you could use spark lines. Spark lines are line charts. Now, why am I calling them spark lines? Because we've removed the axis, we've removed the labels. And most importantly, we're using a principle called small multiples. What we're doing is saying that I don't have to have one big page with one chart. I can have an array of charts. I can have a matrix of charts. And that in itself gives me some insights. That's called the principle of small multiples. So what I have here are little line charts against Chennai, Coimbatore, Cuddalore, Dharmapuri, blah, blah, blah. Excel 2010 now supports these natively. You can find many other software that do this. And you can broadly see the pattern. Okay, there were spikes here, 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 here. So consistently there was this period where there were spikes. Consistently this period where there were spikes. But not in the Deccan, nor in Europe. But it continues here. There seems to have been a dip in the last month in almost every case with the exception of Kanchipuram and Chennai, which also happen to be geographically proximate. Remember, this is another one of those cases where geographic proximity, if it could somehow be modeled here, that tends to have an advantage, but we'll come to that right at the end. You could also have multiple spark lines overlaid on top of each other. For example, if you took the index, imagine that each of these is a mutual fund. Now, the dark blue line is the mutual fund's returns on a day-on-day basis. The light gray line behind it is the Sensex returns. So you can see how it fares with respect to the Sensex over time. So you can overlay these, you can overlay them with multiple charts and get a sense of what is. Spark lines are great for showing trends. You can see if something's going smoothly up, smoothly down, whether there are spikes, and those are the three most common things one typically wants to do with most time series data. If you have data varying over time, consider spark lines. So it's a very logical choice. Or bar charts, for that matter. Bar charts versus spark lines. Let me explain the subtle difference in usage. There isn't much visually that is different about those, except from perhaps an aesthetic perspective. Okay, I don't.
You can pull them.
Okay, how many think bar charts look better? Okay, how many think spark lines look better? It's the same. Okay, see an overwhelming majority of people.
Not gone for bad taste.
Sparklines is less ink.
Sparklines is less ink. Actually, that is a fairly valid point because Edward Tufte, one of the big guys in data visualization, early big guys in data visualization, talks about this data to ink ratio. It says, let's see how much data you have and let's see how much ink you take to print it. Now, the higher your data to ink ratio, the more effective your visualization is. Which basically means if you've got, okay, so let's say next to this, I've got this picture of cloud and I've got rain falling down to tell me that it's rainfall data. I'm just wasting ink. There's nothing additional that gives me compared to if I just wrote the word rainfall, which takes a lot less ink. And if I had the god of thunder and the god of rain also standing next to them to make it look jazzy, that's a total wastage of ink. Now, all of that falls in the realm of infographics, as it were, where the focus is on making numbers look sexy by putting interesting things next to it. Data visualization is based on the principle that data is interesting in itself and doesn't need prompts to make it more interesting, that the data can tell a story by itself. So if you're using a pretty picture next to, so if you, for instance, instead of bar graphs, have beer bottles to show the beer bottle sales, then that's a cop-out because you're saying that, look, bars aren't interesting enough to see. I want to have the beer bottles to make it look more interesting to see. Now, there are a number of cases where you want to do this, okay? But in my mind, that is the differentiation between data visualization and one of the differentiations between data graphics and data visualization and infographics, if you want to draw that distinction. And I fall in the camp of data visualization. The reason I'm saying infographics is not a good thing is not because it's actually not a good thing, it is just that for the purposes of communicating data, there is no need to put in anything else. If it is not interesting, don't show the data or work on making it more interesting. There are enough reasons why you want an infographic. Let me not get into that. Back to bar graphs. One of the conventions in a bar graph is that the bottom represents 0. It need not. Okay? So, if for instance, I had the sales of a company in each of these districts varying between a lakh and 2 lakhs. So now in a spark line, the bottom would typically represent a lakh and the top would typically represent 2 lakhs. In a bar chart, the bottom ought to represent 0 because that is the way most people would understand it. So a bar chart would also mean lesser information being shown because the range 0 to 2 lakhs is what you would have here and only half of that space is being used in the variation. Now what if you said, no, I won't do a bar graph, I'm going to start the bar at 0, I'm going to do the bar graph at 1 lakh and show it beyond that. You could do that, just keep in mind that people are more likely to get confused, far more likely to get confused. And what they are likely to interpret this as. So if this were the sales, for instance, they'd say, oh, this month I've had huge sales, this month I've had practically 0 sales. Whereas fact is probably that you had just twice as much sales here as here. There was 2 lakhs and this was 1 lakh. And the ratios which one is likely to use in a bar graph are less likely to be used in a spark line, where this is more amenable to viewing this as a trend rather than comparisons. Each of those are not shown as discrete values, you just see the movement across
In
those.
this case, given the rainfall does bottom out at 0, so putting the bar graph, you're actually getting information that
Is not there, that may not be interpretable from a spark line. Absolutely. And there are ways of minimizing the data to ink ratio as well. For example, there's no reason to show the bottom parts of the graph or the bar graph. You can just show the top edges of the bar graph, and that could make.
That just becomes a spark line.
No, it doesn't.
You don't join them, but
No,
you have
you-
dots.
no, so it becomes rectangular lines which shows the outline. But that incidentally has been tried and is considered one of the poorest ways of visualizing. Another way of improving the data to ink ratio is rather than reducing the bottom parts, make the lines thinner to the point that they become a single line. That again isn't as effective as as a bar graph. Yeah, like this is coded, exactly. So what you want to do is make the bars reasonably thin, but not too thin. Now this is one of those cases where Tufts principles don't quite match with real life experience. You don't want the data to ink ratio to be absolutely maximized. You want to take it as far as you can until it, until it
So
sticks.
isn't that dependent to some extent on the medium? Meaning on paper, when Tuft started its business where printing color on paper is an expensive proposition, it makes sense to minimize ink, right? But on a screen, it doesn't seem green. So is there actually a difference between the screen and paper when it comes to this kind of?
There is, but not on this particular principle in my experience. What seems to be the predominant driving force still for the data to ink principle is that almost every representation of data tends to use more ink than it needs to, whether it's on paper or screen. So for 99.9% of the people just following this rule blindly, say minimize data to ink ratio, is likely to lead to better visualizations. There's only 0.1% of the people for whom it could go too far and you want to switch them across. And between the mediums, I don't know if there's enough of a difference, but this is too vast a difference for the medium to matter. Let's take horizon graphs. Now this is a slightly more compact representation of data. This is a relatively new one. A horizon graph says, now I've got an area plot. An area plot is nothing but a line graph with the bottom half filled. So let's go back to a line graph. Now supposing this had positive and negative values. A horizon graph becomes more meaningful when you have positive and negative values. But remember, positive and negative could be with respect to a certain value. For example, if you're looking at an index fund and you have values above the Sensex and below the Sensex, you could still have all your returns between 2% and 13%, but still some of them are above the Sensex and below the Sensex. Therefore, relative to the Sensex, they are positive or negative. So you have an area graph, which is nothing but a line graph with the bottom part shading. And then what you do is, okay, bear with me for a minute. You've got this bar graph, line graph. There's stuff that goes above the zero line, there's stuff that goes below the zero line. You color everything that's above in green, color everything that's below in red, and then fold it. So that the stuff that's below the line goes above the line. So what you have are multiple peaks. The red peaks are actually negative, the green peaks are actually positive. So that's what this shows, pitch dark. So that's a negative number, that's a positive number. But I can still see the gradation, how it's as it smoothly moves across. But that's not all. What we do is, now everything is above the zero line. I chop it off at a certain point. I say that everything above this point, I take it from below again and make it overlap with this. So for example, let's take a place that's reasonably clear. So here, you'll see a little bit of darker red coming in again from below. You'll see a little bit of darker red coming in from below, a little bit of darker red coming in from below. What's happened is the top portion got chopped off and it's coming in again from the bottom, creeping in from here. So the intensity is another thing that we can use. So I see a rather dark patch of red here, so I say that's more negative. I see a bright green patch of, I see a bright green patch here, that's more positive. So we're using the combination of the intensity of the color as well as the slope of the lines to both show a fine-grained variation so that I can see if there's tiny differences as well as broad variations. I look at the color, I see the broad variations. I look at the slope of the line, I see a fine-grained variation. This is called a horizon graph. You don't find this too commonly, but in a financial representation, this tends to be quite useful.
Definitely for the index
Precisely. Yeah, we did this for a couple of clients who said, no, this is exactly the kind of visualization we want, but we want to oh, okay, no, yesterday it came down and activates something, that's all. A simplified version of the same thing is a heat map, where you say, I don't use position, I just use color. So on any given day, I have a certain color. If it's green, it's whatever it is. One extreme of color is positive, it's another extreme of color is negative. One extreme of color is high, one extreme of color is low. And you can use a number of gradient palettes for it. This, for instance, uses the red, yellow, green palette, which is actually a very, very bad palette. You'll find that most of the visualizations that I do uses the red, yellow, green palette. That's sort of in the color word as bad and either as using Comic Sans or as using a pie chart. It's really bad. But I'm too lazy to change the settings. So there are many other good palettes to use. For example, the blue-orange gradient is considered one of the best gradients. So this is another way of or you could have a stream graph. Now, a stream graph is like an area plot, smoothened out and laid out one on top of the other. And you can see, so these are in fact words on Twitter, and you can see at what time which word on Twitter became bigger, which word on Twitter became smaller. Looks great. I have never ever used this in a project, or rather, every time I've used it, we end up moving to other better representations. So this is one of those cases where sometimes you want things to look nice and cover up for the fact that this data doesn't have enough of a story to tell, which is a very good way of putting it. That's what it is. Or you could do a jitter plot. Now a jitter plot flips the axis. Here you say the position, earlier we used the height to represent the value. Here we use the horizontal axis to represent the value. So most of Chennai, or most of the months Chennai gets zero rainfall. Most of the months Coimbatore gets zero rainfall. But occasionally Chennai gets fairly heavy rainfall on a day. Erode again gets fairly heavy rainfall on a day. You can see that Cuddalore is mostly clustered relatively
This
low.
is by day, right?
This is by month actually. Yeah. So each dot is a month.
It's like not more than day.
Oh no, it's for 1,200 months.
Oh, okay, so for the whole century.
For the whole century. But I think I've taken a subset here. This isn't like 1,200 points. I don't know the original data set. So looks like this is a little more clustered to the left. This is perhaps a bit more spread out. That's a lot more spread out. And that indicates different kinds of pattern. Now, the visualization that you saw right up front in my first slides is a variation of the jitter plot, where you have both positive and negative segregated in different ways. So that's another way of doing it. Now here, the vertical axis does not have any significance. So when you get the jitter plot here, all we've done from top to bottom is move the points out so that they are visible. That's all. There is no significance to the vertical axis. It's really only the horizontal axis. In fact, you could plot them all on the same horizontal axis. The trouble is then it becomes difficult to see. Then you could say, okay, if the dots fall one on top of the other, then maybe I could make them bigger, sort of like water droplets coalescing to form bigger droplets and have a different kind of visualization. That is a perfectly valid visualization. However, for one dimension, that's not proved too good. It tends to be a little tough to see. It works rather well in two dimensions, and I'll try and show a variation of that in a few minutes. Then there's the box plot, which is one of the oldest ways of showing distributions. You say, that's my range of values, that's the median of the values. So on a typical day, that's what my rainfall might be. And that's the bottom 25%, that's the top 25%. So half of the months, my rainfall is in this range, half of the months, my rainfall is in this range. And you can fairly easily see here that Dindigul and Erode get relatively less rainfall. So half the time they get fairly little rainfall, whereas Kanyakumari clearly gets a whole lot more rainfall. Chennai gets a reasonable bit of rainfall, unbelievable as that sounds, and so on. Or you could have bullet charts. Bullet charts are meant for representing a lot less data, but have a very specific purpose. You could say that I've got revenue. My actual revenue is this blue line out here, and based on the forecast for this year, I will end up at this much revenue. My performance last year was this much, or my target was this much. So this is what I was hoping to get, or I'm hoping to get. Looks like based on the current forecast, I will exceed it. Now these gray bars behind tell me what is considered bad, okay, good. So if my revenue were to end up in this dark area, I would have been considered performing bad. If I ended up here, it would have been okay, and if it were here, it would have ended up good. So profit revenue-wise, my forecast looks like it's going to be good and above target. Profit-wise, I'm going to miss the target and I'm going to be average. Order size-wise, I'm going to be bad and significantly miss the target. New customers-wise, I'm going to significantly miss the target, but I'll be in the good region. Sorry, that's the average region. I'm going to be average. Customer satisfaction-wise, not only am I going to exceed the target, I'm also going to be up in the best region. So satisfaction and revenue, life is good. In the others, it varies from bad to average. So that's another relatively compact way of showing this. Now, up to now, we've looked mostly at one-dimensional data. I'm going to continue one-dimensional data for a short while, but represent it in more than one dimensions now, which is not a very efficient way of doing it, but still we'll talk about a few. So this is a bubble chart. Now here we're using size to represent the magnitude, and the color is actually not being used to represent it. It's randomly colored. So here is a case where you just prettified it. It looks nice. Now, when asked the question, which is the largest? Maybe this one. Okay. Is this one larger than this one? No clue. Absolutely no clue. But looks pretty. All we're doing here is taking the size of the bubbles to be a value and packing them all together so that it doesn't take too much space. And that's what a bubble chart. But there are lots of terminologies about these different people. On Excel, for instance, a bubble chart means a slightly different thing. This is what some people call a circle back layout. Doesn't matter what it's called. You've seen it, you can remember it. Then there's a calendar map. This is another way of representing one-dimensional data, provided it's arranged, it's on a daily basis. So you have on one axis the day of the week, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and the months. So this is literally a calendar, and on the calendar the values are colored just like you saw on a heat map. This is good for showing weekly patterns. So for instance, you see that the values are all low on Sundays. You can also instead arrange it as day of the month and the month, which you saw earlier, perhaps in the education data, where you found that people born in the months of, very few people were born in the month of August. Those born on the 10th of any month have a very low average mark, stuff like that. So depending on the nature of your data, you could arrange it in a grid, breaking it up in various ways, and calendars, either on a weekly basis or on a monthly basis, are a good way of showing data that is organized by team. Yet another way of organizing data is a tree map, but here is where we start getting to the second dimension. A tree map is a very powerful structure. It's a series of rectangles whose size is proportional to the value. Now, earlier I said that size isn't a very good way of allowing you to compare different things, which is true, but size is a fantastic way of showing relative priority. Now, if you took this plot and said, look, I'm not likely to be comparing whether this is larger than this or not. I just want to know if what's important, what's not important. Very easy. In this say, look, all these small circles are not important, all the big circles are not important. These are somewhere in the middle. You're not worried about in prioritization. You're not too fussed about the exact cutoffs. You're more fussed about the value. And then you can use a color to show the actual performance. And it's a little easier to compare colors than it is to compare area, especially if it's near each other. So tree map has boxes. The size of the box is based on one value. The color of the box is based on another one. It's sort of like a combination of a bubble chart as squares and a heat map as the color inside. This is perhaps the most commonly used visualization that I've created.
It does give the illusion that you're actually looking at a map where, for example, the dark spots are like cities and the others are rural areas.
Does it give you that impression?
To me, because the cluster of red dots, they actually look like farms when you see from the air. So you would see a lot of houses, in a village.
Right. So you're saying it seems to represent geographic proximity there. Yeah. Okay, that's actually the first time I'm hearing this comment.
The first time when you showed last time, that's what first thing I was thinking, because this is the so these are cities where there are more urban schools and they're the rural area where there are more private schools.
Interesting. Okay. I'll check this out with a few more people to see if they got that impression. In which
The
case,
only place I've seen this kind of images.
that.
I think I should say that I also get the field sort of
Geography.
geography thing, but I don't impose that. So in the sense that it visually looks like a map of some rural landscape, but when I see it as a chart, I don't necessarily do that kind of geographic.
In all the cases we presented, it usually takes people a few minutes to get it, and then once they get it, the integration becomes easier. I don't know if that model has persisted for long, especially.
Only problem here is that when the colors blend into each other, I'm not sure if that's by design or if that's a flaw.
It is a shortcoming, and there are ways of improving that as well. There are two ways in which colors could blend. So one possibility is if you have lots of little points here and your eye's resolution is not good enough to differentiate between these, then the colors could tend to blend. The good part is that happens more often in the areas that typically represent lower priority. So where it blends, you don't care. So if you have, let's say that all this represented the sales of various branches. Now what happens is the smaller branches, I don't really care. All the small branches are bleeding. Yeah, but look, if my top 4 branches are doing well, that more than covers up for at least half of the sales, and if the next 4 were doing well, then it covers up for all of it. So I'm actually not too worried about it. So that is a lesser shortcoming. The bigger shortcoming is where the gradient itself is chosen in a way that it's very tough to differentiate between some of these. On this monitor, for instance, it's only about half as clear as it is on my monitor, because obviously I've set the palette to work well on my monitor, not here. And I could use the gradation, I could use the properties of the monitor a little bit to improve this. But a bigger win would come when I extended the palette itself. There are certain high range gradients. For example, what if I said I'm not going to stop at red or green, I'm going to take it further to dark red and take it to dark green. Now I have a wider range of colors to play with. And then I say, I go even beyond that all the way to black, except for the fact that pure black is very confusing, so I stop short of pure black. But then I have an even wider palette. And then I say, okay, wait, most people tend to interpret blue as being even better than green. So what if I could add blue into the mix and have an even wider palette? Things like that. So it's possible to extend the width of a palette, which then starts increasing the granularity. That's one way. Secondly, if there are actual limits. So for instance, if your profit goes below 0, then that's a really bad thing. If your marks are below your pass marks, then that's a really bad thing. You could then say anything below a certain cutoff, I'm going to just straight away use a different color, black, for example. So any black marks that I see are black marks on that division, department, district, whatever. Or you could use a vary wide. A vary wide is where the width represents something and the height represents something. So for example, if I had a series of products in a bag, and this is my sale, and the height represents the profits that I get from that. The width represents the sales. So I'm selling a bit of savings accounts and I get decent profit from it. I'm selling a lot of fixed deposits and I get much lower profits from it. I'm selling a little more of current accounts and I'm getting a lot of profit from that, and so on. Now what happens is the area has a significance, the width has a significance, and the height has a significance. I'm able to compare the heights really well and able to say that this product, let's say commercial loans, is my highest margin earner, even though it's a relatively small product. Whereas this product, let's say it's working capital loans, is my worst product from a margin perspective, even though I'm selling a whole lot of it. That's the amount of profit, volume of profit that I'm getting. So where am I getting the maximum profit? Probably from here. And where am I getting the least profit? Probably from here, no, I think this is probably small. You're not quite able to compare the areas too well. You're able to compare the heights extremely well. And you're able to compare the widths a little bit, somewhere between the two. So you can pick and choose your dimensions in a way that it maps to what you want to compare. So the one you want to compare the most, make sure that it's the vertical axis. The one you want to sometimes compare, make sure that it's a horizontal axis. Order them in a way that makes the comparison easier. For example, you may want to simply sort it from the largest to the smallest, or vertically, or you may want to sort it from smallest to largest on the horizontal axis. You could make sure that the thinnest is the first, the thickest is the last. So that way, the order itself tells you something more about the letter size, and comparison becomes easier. Area comparisons don't even bother. It just gives a rough sense of prioritization. You could go to hierarchical packings. So tree map lets you show hierarchies. I can have groups of boxes within groups of boxes within groups of boxes, and so on forever. You can do the same thing in a circle packing. Circle packing is again where I can use the color to represent something and I can use the size to represent something. as long as you are not interested in comparing the sizes very carefully and the color you are comparing to a certain extent, you've got a high gradient palette. This is as good as a tree map, except that it takes more space. So in that sense, it's not got, it doesn't have the best, data link ratio is the same, but it uses a lot more space than it needs to. But if designed well, it could look prettier than a tree map. And just a couple more. You could use a bubble chart. Now, if you remember, I called something else the bubble chart earlier, and I called this the bubble chart again. There is enough confusion on the terminology. But this chart lets you show a large number of dimensions at one shot. So you have the horizontal position, you have the vertical position, you have the size of the object, you have the color of the object, and so that's 4 dimensions already. And if you animate it, you can have a 5th dimension which shows you the movement over time. And there are other ways of adding multiple dimensions to it, but this is one of those representations that lets you put in a lot of data into one chart. And if done carefully, can give you a lot of insights. For example, this shows you the relative benefit of various marketing campaigns. Each bubble is one campaign, online campaign. Now, what the horizontal axis shows is the percentage of people that searched for, sorry, this is not campaign, this is a search keyword. So, the more to the right it is, so a lot of people are searching for the word pi on this website. A lot of people are searching for the word omicron on this site. A lot of people are searching for the word xi on this site, but very few people are searching for lambda. The conversion is once they search for it, do they buy something? So a lot of people, when they search for epsilon, are buying. Very few people are buying omicron and sigma. So if you take this line, anything to the bottom right, so a lot of people are searching but not buying. So which means that's a product in demand, but you don't have it probably. Either you're out of stock, or your pricing is not good, or you have a product problem. If there's something here, few people are searching for it, but the few that search for it buy it. So you got a fantastic product, you have to market it more. You got a marketing product. You're sub-optimizing what you have. Now the size tells you the sales. So my biggest selling product is sigma. My worst selling product is mu probably, or pi. Not sure, but it doesn't matter. I'm not particularly worried about it. This is the most worst performing product or whatever. The color tells you the relative growth. So this is growing slightly. This is growing fast. This is shrinking fast. This is the one I'd be worried about. This is shrinking fast too, but because this is bigger, if I had to choose one thing, if I had to make one phone call this morning and scream at somebody, it would be the guy who runs the Omicron product. And then, if you had a play button on it and let's see move over time, then that would work. Do a Google search for Hans Rosling and watch his TED talk. He makes amazing use of this and creates a beautiful visualization of it. You could take heat maps and extend that to 2 dimensions as a heat grid. So one dimension could represent one set of values, another dimension could represent another set of values. This is rather similar to the scatter plot, except that the dimensions are discrete. Instead of searches being any real number, you have, let's say, searches 0 to 1 searches, 1 to 2 searches, 2 to 3 searches. In some cases, things are naturally categorized. For example, if these were my customers, each customer's name, and these were the types of complaints that they made, you can say, okay, this customer is complaining a lot. And a lot of complaints are being made about this particular type of complaint or this type of product. A lot of complaints here about this type of product. And you get the matrix of similarities. And this last one. Maps. Now, maps are a great way of visualizing geographic data. They have a very serious problem. The problem is that the largest geographies are implicitly assumed to contain the largest value. So if on this map, for instance, you would assume that now this Bangalore, tiny, and there's Belgaum and Uttarakhand, reasonably large. Population of Bangalore is at least twice as high as these. You would sort of, and if you look at the, let's take an example. If Bidar had a population 10 times higher than all of these, the average color of this map will be nothing like the average color that you see on this map. So, geographic representations are great to a certain extent. This is called a choropleth, where you take each geographical division and cover it. If they are equally spaced, equally sized, or if the size represents the priority of the metric that you are looking at, then they are fantastic visualization. Otherwise, they can be quite misleading. Keep that in mind. Network diagrams are ways of showing relationships. So the distance between objects and the lines between objects show that they are connected, and you you can have a proximity metric. You can say that I've got all of these tweets. Whenever people talk about this tweet, then they're also talking about this tweet. So these two words are very technically related, but they very rarely talk about some other tweet, so that's very far away. You could also do that as a chord diagram where you say, okay, I've got one word. Whenever people talk about this word, they also talk about this word a little bit. They talk a fair bit about this particular word. When they talk about this word, a lot of them are talking about this particular word as well. And a relatively smaller number are talking about this word, but very few people are talking about this word. This is too messy to read as it is. Invariably, it is presented as an interactive diagram where you hover over each one of those, and only the branches from that are shown. The rest get muted or hidden. So, let me end with a cluster scatter plot, which I think I may have shown in one of the earlier presentations. What this does is takes a set of values, takes the correlation between every pair. So this number is the correlation between the Australian dollar and the euro as a currency over a 6-month period, and the scatter plot between these. And using the principle of small multiples, has a lot of scatter plots and a lot of numbers, each of which is colored and grouped in a way that the most similar groups come together. So this is a way in which you can represent the similarity between any pair of a set of metrics. It could be, for instance, how similar are the people who talk about, let's say, US elections and baseball statistics. And it's not just two. So how similar are the people that talk about baseball, basketball, cricket, football, polo, golf, whatever. And you take the similarity between each of those, cluster them, and you say, oh, okay, the people that talk about polo are usually the ones that talk about golf and billiards, but they are very different from the people that talk about cricket, football, and baseball. That's sort of thing to come. I'm going to stop here. We've barely scratched the surface of visualizations, but what I've done is giving you a sense of the kinds of visualizations, especially with relation to one-dimensional data that you could use. There are a number of tools that I've not yet talked about that help you create these visualizations. We'll be covering some of those in future talks. But remember, when you pick a visualization, there are certain aesthetics, as they are called, like size, shape, color, etc., which you can translate to the numbers. And the choice of aesthetic depends on what you want to compare and what you want to compare carefully versus what you roughly want to depict. Make sure that that's the back of your head when you're picking visualizations to show your projects. That's pretty much it.
Cluster scatter plot